Okay, so section 1-3 deals with graphing lines, deals with lines all the way around, okay? So 1-3 lines. Okay, now one thing that hopefully is burned into your brain that's almost like a reflex if I just say it. I mean, if I say y equals m, then what do you say? X plus b. Good. That's something that you gotta know. The equation of a line in slope-intercept form, y equals mx plus b. Now, I'm guessing that if you had Mrs. Neal or you had Mrs. Thomas or whoever you had for math previously for algebra, they might have shown you when they're graphing lines like a longer way of graphing lines, and then hopefully they showed you the shortcut, because we're going to use the shortcut method from this point after I do one example. So if I give you something such as this, y equals 2x plus 1. The long way, when I first teach how to graph lines, is you make up a little t-chart. You don't need to write this down. Okay, a t-chart, and you plug in values for x. You plug in whatever you want for x. I usually plug in like 0, 1, and 2 because they're easy. All right. If I plug in 0 for x, 2 times 0 is 0, plus 1 is 1. If I plug in 1 for x, 2 times 1 is 2, plus 1 is 3. If I plug in 2 for x, 2 times 2 is 4, plus 1 is 5. And then you graph it. 1, 2, 3, 4, 5. 0, 1 is up 1. 1, 3 is over 1 and up 3. 2, 5 is over 2 and up 5. If they all lie in a straight line, you probably did it right, okay? Not necessarily, but you probably did. If they don't all lie in a straight line, you screwed up somewhere, okay? Connect them. Ooh, try to make a straight line, okay? And it looks sort of like that. That's the long way of doing it, okay? The shorter way, and I think I've said this at least once in this class over the last few weeks, slope, rise over a run. Does that sound familiar? Okay. Slope is rise over run. M is your slope. B is your y-intercept. That's why it's called slope-intercept form. Okay, it's your y-intercept. It's where it touches the y-axis. So a quicker way of graphing this one, and this is the way we're going to do it in this class, is you always plot your y-intercept first. Okay, you always plot your y-intercept first, which is positive 1. So you go up 1, and then your slope, you use your slope, which is 2 in this case. Okay, and normally, I mean, myself included, I don't really like fractions, but the one time in math where I actually prefer fractions is we're talking about slope. I mean, slope, we said, was rise over run. It's actually explained to you as a fraction, okay? So I'm going to make my slope a fraction, 2 over 1. If it's not a fraction, make it a fraction by putting a 1 under it, okay? And then your slope is 2 over 1. You're going to rise 2 and run 1. So from this point, you're going to rise 2 and then run positive 1. You only need 2 points for a line. I plotted 3 over here. You only need 2, okay? And this is the exact same line. Same line, okay? Does that look familiar doing it this shortcut way? Have you guys done that before? The rise and run? And,
yeah,
okay.
So you only have to change the one that's with the x.
Change what?
The number.
Oh, this one's a fraction? If you want to make it a fraction, you can, but I don't like fractions except for slope, okay? So I'll leave this one alone. Okay. And if it is a fraction, it is a fraction.
So
What's that?
So would you go up 1 or over?
Up 1. This is your y-intercept.
Oh,
Y runs up and down. It tells you, now that said minus 1, you went down 1. Let's try a couple more examples. Y equals 2/3 x minus 4. Okay, this one's a teensy bit easier because our slope already is a fraction. Okay, and again, if it wasn't, you just put a 1 under it. Okay, just like that. That wasn't that hard, but it was a little bit of work. So you look at your y-intercept first. It's negative 4. That tells you to go down 4. It always tells you where to go up or down. Doesn't say anything about left or right. Okay? So we go down 4. 1, 2, 3, 4, put it down. Then your slope is 2/3. We're going to rise 2, and we're going to run 3. So from this point, we're going to go up 2, and we're going to run positive 3 to the right. You rise up and down, you run back and forth. Okay? And there's our line. Okay? Yes, ma'am?
Okay, where did you get like the T-chart thing?
Oh, this is the old, like, I'm just, when I teach graphing lines, the first thing I do is I do it this method.
How do you know like what numbers fit?
How do I know what?
How do you know what numbers fit?
You can plug in whatever you want for x, whatever you want. Okay, I use 0, 1, and 2 because they're easy. But again, this is not the way we're normally going to do it. Okay, I mean, if you want to, you can. It takes longer. You actually have to do some computation. It's a whole lot easier just doing the shortcut method. So, okay. Let's try this one. How about y equals negative 4/5 x plus 3. Okay? So again, if you want to make a t-chart, plug in your values, you can, but what I'm going to do is my y-intercept is plus 3. So I'm going to go up 3. Okay? Now, actually, I tell you what, I'll put that negative right in the middle. Right in the middle. Okay? So it says negative 4/5. Now, I shouldn't have put that negative on the 4 first. It kind of tips it off. Does the negative, it's right in the middle there. Does it go on the 4 or does it go on the 5? A lot of students say, well, it goes on both. Well, be careful. If it's on both, a negative divided by a negative is a positive. And it's not positive, it's a negative. So does it go on the 4 or the 5? It doesn't go on both. It goes on either one. It doesn't matter. It really doesn't matter. I almost always put it on the top one, but it doesn't matter. Okay? So this is going to sound a little weird here, but you're going to rise negative 4. Well, you think you rise, you go up. Well, if you're rising negative, you're going to go down. Okay? So you're going to rise down 4. 1, 2, 3, 4. And then I'm going to run 5. Now be careful. Some students say, so we run negative 5? No. I chose to put the negative on the 4. We're going to run positive 5. So we're going to go down 4 and right 5. Now what if I chose to put the negative on the 5? Would that have been okay? Yeah, it would have been. Here's what would have happened though. We would have risen 4, but then ran negative 5. What do you think that means? We're going to go left 5. So guess what? Different point, same line. It doesn't matter, okay? It really doesn't matter, okay? You guys are the quietest class I've ever taught, I think. Just nod your heads. Does this sound familiar, or is this like, okay, it's, all right, good, all righty, good. So it's something, it might have been, you didn't do a whole lot of this in geometry last year, but it's stuff that you should have done in algebra quite a bit, hopefully, in algebra. Graphing lines is a big one. Okay, let's try one more, and then we'll actually start some of the problems. Well, yeah, we'll start some of the problems. So if I give you y equals negative 2x plus 3, okay? And I hesitate doing this. I'm going to show you what you don't do. Don't do this, okay? Here's what some students will do. And again, I said it twice, I'll say it a third time. Don't do this, okay? They'll look at the plus 3, and they'll say go up 3. Put a dot. How are we looking so far? Yep, good. Then they'll look at the minus 2 and say, oh, go 2 left. No, okay? This tells you where to go up or down. This tells you what to do after you get to that point. I'm going to make negative 2 a fraction over 1. So from this point, I'm going to rise negative 2, which means I'm actually going to go down 2 spots, okay? And I'm going to run positive 1, which means 1 to the right. And that's what our line looks like, okay? Question on any of these?
We can always put them over 1, right?
Yep. You can make anything a fraction if you want by putting it over 1. And this is, like I said, I don't like fractions. I'm pretty good at doing computation in my head even. I'm pretty quick with that. But even I don't like fractions. I like nice round numbers, except for when we're talking about slope. Slope's the only time I can think of where I actually prefer a fraction. So, okay. All right.
So you always base, like, you went down 2.
Yep.
From
the point that I first plotted. Yep. Yeah, and that's another thing students will do is watch. They'll do this from time to time. They'll go up 3, put a dot. Then they'll go down 2 over 1. So they'll go down 2 over 1. What did they do wrong?
You didn't go off of the 3.
Yeah, they went off from 0, 0. Okay, don't go off from 0, 0. Go off from the point that you plotted. Okay, plot that first point. Then from that point, do what it tells you to do. Okay, good question. Okay, now in all honesty, the assignment that we're going to do is related to this, but the problems aren't exactly like that, okay? So what I'm going to do is this. Actually, I'll tell you what. I'm going to give you a couple more examples, then we'll dive into it. And we're not going to do many. Like I said, I want to give you guys at least a half hour to work on your assignments if you're not done with them yet. Now, some of what you're going to see in the assignment is something like this. If I gave you a line like this, and they ask you, they're going to ask you, like, give me an equation of this line. give me an equation. They're going to give me a picture of a line. And they're going to say, give me the equation of this line right here. Okay? Well, I mean, in order to graph this thing, it's going to be y equals something x plus something. Start with a y-intercept first. This number right here. Any idea what this number is going to be right there?
5.
Why 5?
Because the dot's at 5 spaces.
Well, this dot's at 2 spaces.
The one on the y.
It's on the y-axis. Positive 5 or negative 5?
Positive.
Because it's up 5. Okay, so you're going to put a 5 right here. Now the slope, okay, what you do is use your definition of slope. Rise and run. To get from this dot, or this point, to this point, it sounds kind of weird here, because it's going down. How far do I rise to get from here to here? Yes, sir.
-4.
Negative what?
4.
1, 2, 3, careful.
4 over 4.
Careful. I start right here.
1, 2, 3, 5.
You count really good, okay? Eventually you did, okay? So you rise, so is it 5 over how far?
1 or 2.
Over 2. And I tell you what, maybe you're thinking this, I don't know. Sometimes students, they say, well, do you count 0 or do you like not count 0? 0 counts. 0 is something. If you don't believe me that 0 is something, skip your first test. You skip your first test and get a 0, is that going to change your grade?
Yeah.
Hopefully it just destroys your grade. Seriously, not to be mean. If you get a 0 on a test and your grade doesn't go way, way down, what does that tell you? Your grade,
Is amazing.
no, it's not. It stunk before, okay? I've had people get 20% on tests and their grade actually went up. That's sad. That tells you they had like a 10% before they took the test. So that was a long time ago. But anyhow, 0 counts. So we went down 5 over 2. So 5 over 2, right? Negative 5 over 2, okay? Does the negative go on the 5 or the 2?
Don't matter.
It don't matter. Can I put it right in the middle?
No. Well, yeah.
You can. I usually don't, because if you put it right in the middle, I mean, is that a negative, or maybe it's just a fraction bar and my marker left the, you know what I'm saying? It's kind of hard. It's kind of hard to tell. Okay, I'm not saying it's wrong, but it's like, did I put a negative there, or did I write the fraction bar? My marker left the board for a second. Yes, ma'am.
But since you wanted to swap the picture and you already have the 2 dots, would we go and put the -5, put it as -5 over 2?
Say that one more time.
Because you said you could have the negative on either one.
Uh-huh.
But since you already have it graphed with the 2 dots, would we just go off the dots?
That's an excellent question, and here's the answer. Okay, this is sort of tricky question here. How many points are on that line?
2.
Good guess. No, there's not 2 points. I plotted 2 points, but this line connects. There's an infinite number of points on there. Okay, so I mean, I could have. I mean, this point up 5, left 2. I didn't put that point isn't on there. It isn't. I just said it was. I didn't plot it, but it's on there. Okay, so I get what you're saying, but I'm going to still go back. It doesn't matter, because again, there's not 2 points on that line. There's an infinite number of points on that line. It really doesn't matter. Okay, so that's a good question though. Yep. So just to make it easier, don't worry about it. One or the other, just not both at the same time. Okay. Any other questions? Okay, so let's do this. I'm gonna, like I said, just do a couple, 2, 3 problems with you guys, and then we're going to, let me get this air played. I'll turn you guys loose so you guys can work on your assignment. Okay. Where's that? There it is. I'll share this with you guys right here. What the heck? I'll share good news. My son is a 5th grader now who's got an iPad. They assigned him an iPad. He found out the other day how to email, so he's been emailing me all the time during school and all that. Say, hey, Dad, how you doing? Love you, miss you, all that. Just makes you feel good. So anyhow, I'll share that with him. So he is cute. So thank you. So is my daughter. But she's almost in high school, so guys, hands off. I'm serious. Okay. It's okay. You can bother my daughter if you want. If you don't want to pass this class, I don't care. That's not a joke. You can date my daughter when she turns 35. Just keep laughing like I'm joking. Okay, section 1. All right, so we look at exercise 3, and I tell you what, I can trust you guys. Go ahead and fire up your laptops, because you guys, people know about you can't see that. Can you, Fosmore?
No, I don't know.
terrible eyesight, I have glasses.
Yeah, it's too small. You guys can't see that. So I'm gonna trust that you guys are, where you're supposed to be and not jumping ahead and all that stuff and emailing. Not doing what my son's doing, is emailing me instead of paying attention to the teacher. Even had his buddies emailing me. Nolan Chard emailed me too, and I'm like, dude. So, okay. Okay, anybody, you guys know Nolan Chard? Anybody know him? Man, we're going camping this weekend, me and my son, and he wanted to bring Nolan along. That kid eats like you wouldn't believe. Oh my gosh, we have to stock up at Myers before he comes, and then after he leaves, when he spends the night, we have to stock up again, because he just, so. Yeah, I remember one time he spent the night, and the next morning I was like, what do you guys want for breakfast? He goes, I want pancakes. I go, well, you don't have any waffles? And he's like, no, you guys don't have any waffles. I'm like, what? He's like, yeah, you guys are all out of check. He's like, what, are you going through our cupboards and everything? One more thing with you. I bought my son, you guys ever eat donuts from Sweetwater's?
Yeah.
I remember I got my son a whole bunch of donuts one day, and the next day he didn't eat them all. And Nolan spent the night. My son knows. So when Nolan spent the night before he got there, Cameron told me the next day after Nolan left, he's like, Dad, you'd be proud of me. I was like, what's that? I said, I took the donuts, I put them way in the back, and I put 2 boxes of cereal in front of him so Nolan wouldn't find them. Okay, let's look at exercise 3, okay? The first one. It says use the graph to write an equation of the line, okay? And then they need to interpret the slope, interpret what it means. Slope is all about rate of change, okay? Rate of change, okay? So when we look at this, okay? Now, I want to make sure you understand, okay? We're going to talk about this, but we're also going to use some common sense here, okay? Forget about exercise 3 just for a second here. I might have used this example before. If I did this right here, is that a 90-degree angle?
No.
Why is that? Anybody disagree? That's a 90-degree angle. What'd you say? Because of the box. I just drew it really, really poorly, okay? If I go like this, is that 90-degree angle? No?
No.
You're certain it's not?
I'm sorry.
No.
Why?
There's no box.
Oh, whoa, hang on. The box says that's definitely 90, but just because there's not a box, that
But
means
it could be.
that's a better answer.
Yeah.
Now, what do you think? You think it probably is or probably isn't?
Probably is.
Probably not. Oh, hang on. With me, my handwriting, the chances of me drawing a perfectly 90-degree
It's
angle,
an 89 degree.
That's probably like
91.
89.7.
or 91 point something, okay?
Yeah.
But I mean, what I'm getting at is this, okay? I mean, the chances of me even using a ruler, I mean, rulers aren't perfectly straight, okay? Chances of me drawing a perfectly straight 90-degree angle is pretty slim, okay? But it looks more like a 90, and it's pretty darn close to a 90, probably not exactly 90. What I'm getting at is this. Just because something looks a certain way doesn't make it so, okay?
That's a nice life lesson too.
There you go. Okay, so what I'm getting at here is when we look at exercise 3, it says we have to have y equals mx plus b. All right. And so what I'm getting at, you might want to look at your computer right here. What does it look like the y-intercept is? Where does it look like it touches the y-axis? Okay, but I just need the y value then. You're giving me too much information. 0. Now I said it looks like 0, okay? Now look at what this is all about though. They're plotting the cost of a meal in dollars and how much of a tip you leave, okay? Does it make sense that if your meal costs $0, you're gonna leave a 0% tip? Does that make sense or not? Yeah. If you don't get a
Why doesn't that make sense, Garrett? You don't pay for a meal.
Because you're not
you
gonna
take
get a
it
meal
later.
for $0.
Well, you haven't ordered yet, okay? You haven't actually paid for it. But if you paid nothing for the meal, you're not gonna give them any kind of a tip,
I
are you?
can see
You didn't get a
Garrett.
meal.
From now on, I'm gonna think of Garrett walking into a restaurant. being
Sitting
like,
down,
I'm not here to buy anything.
but here's $20.
Yeah.
So, all right. So I'd like to be your waiter then. So it does make sense, though, other than Garrett, that the y-intercept would be 0, okay? Because if you don't have any meal, it's going to be, you're not going to leave a tip, okay? So it's going to be mx plus 0. Well, what's our slope, okay? Well, to get from this point, 0, 0, now, again, this may sound stupid here, but it looks like that's the point 10, 2. Are you pretty certain it's the point 10, 2 or not?
Yeah.
Are you certain it's 10, 2?
Yes.
Why?
Because it tells you.
It tells you it's 10-2. If it didn't say 10-2, it could be 9.9, 2.1 for all we know. We don't know. But it's 10-2 because it says 10-2. So how do you get from 0, 0 to 10, 2? How far do you rise?
You rise 2 and
Rise 2 and you run 10. Rise 2 and run 10. So we have y equals 2/10 x plus 0. Now we need to clean that up. 2/10 simplifies to 1 over what?
1/5.
1/5 x. And the computer might take plus 0, but you don't really need it, okay? Now, you guys can answer this because you're looking at your computer screens. Are you going to type in y equals 1/5 x?
No.
If you do, it's going to say it's wrong. You need to type in what?
1.
They already have the y equals. Don't type y equals. It'll say you're wrong, okay? Okay, so what does that mean, okay? What does that mean? Well, 1/5, another thing, I'll do this. 1/5, I'm going to put this off to the side. If you really want to make decimals, and I believe the computer will take a decimal, that'd be okay, would be 0.2 or 0.20 x. Y equals 0.20 x. I think it'll take either one of those for an answer, I'm pretty sure, okay? What does that mean, 20 cents, okay? Is it the cost of the meal increases 20 cents for every dollar spent on the tip? Is it the cost of the meal increases 50 cents for each dollar spent? I mean, we know the tip is 20 cents. We know that 20 cents is the slope, so it's either going to be the top left or the top right, okay? So what do you think? We're graphing our meal and then the tip. Every time your meal goes up $1, your tip is going to go up 20 cents. Does that make sense or not? Okay, so which one is it? The top right? Okay. The tip increases 20 cents for every dollar spent on your meal. Yes, ma'am?
Should we not put the plus 0 or is it up?
I don't know.
It doesn't matter.
It doesn't matter? So, and I'll be right in front of you. For this entire year, if somebody says, is it this or is it that? I don't know. The computer, from time to time, a year from now, we're going to be doing this question with another class, and I'll be like, I don't know. So, okay, let's look at the next one. I'm going to skip number 4. Let's go to number 5. Question number 5. Same type question. All right. Okay.
Is wrong with this graph?
That little weird thing at the bottom corner?
Yeah.
Okay, just so you understand, that's a good question. Somebody asks that every year, okay? This little crooked thing right here, all that means is on the vertical, they're counting by whats? 50s, okay? So, if up here is 350, that'd be 300, that's 250, 200, 150, 100. That one should be what? If you're counting by 50, it should have been what, 100? Or wait, 100, it should have been 50. It just means instead of using a whole bunch of space, it's just saying this part isn't evenly spaced. You see what I'm saying? It's just condensing it, okay? You don't really need that. Okay, so in this case, it looks like the y-intercept is what? 100. Are you certain? Does it say that it's 100? No, it doesn't, okay? I'm going to put y equals mx plus b. I'm going to put plus 100, but we'll see if it is. We'll see if it actually is, okay? So what does our slope look like here? How far, in order to get from this point right here to this point right here,
They rise 2 and they run 100.
careful, I'm glad you said that. They rise to, you rise what direction?
They run 2 and they rise 100.
Okay, but we don't want to do, let's do rise over run. So how far did they rise?
100.
100, and they ran how far?
2.
2. So 100 over 2 x, well, let's make it, instead of 100 over 2, let's make it 50. Now, we said it looks like 100. Is it 100? And don't say, yeah, it is, because I already clicked on it, and the computer said, yes, it's right. Okay, that's not good enough, okay? You're not going to have your computer when you're taking your test. Did anybody click on it and found out it is 100? Okay, it is 100, but let's find out why it's 100. Yes, ma'am.
Because it says 600.
No, it don't.
Where? Does it say it or not? I didn't.
On your graph, it shows.
Well, I mean, down here, that's what we're saying. It looks like it's hitting 100. And I will tell you, it is hitting 100, but I want to prove it that it actually does. Think about it this way. Your slope is 50 over 1. That means every time you go over 1, you're going to go up 50. Every time you go 1 to the right, you're going to go up 50. 1 to the right, up 50. What's another way of saying go 1 to the right and up 50? Every time you go 1 to the left, you're going to do what?
Down 50.
Down 50. So, right here at 2, you're at 200. Okay? Go over 1, you're down to 150. You go over 1, are you down to exactly 100?
Mhm.
Yes, you are. Okay? It looked like it, and it actually was. And what's this even about? I don't even know what this is. Savings account? Number of weeks? So your slope is 50. What that means is every time you go over 1, you go up 50. So what's that saying here? The balance is increasing $50 each week. $50 each week. Okay?
Wow. That's good money.
Wait, what?
What's that?
50x plus 100.
Say it again.
50x plus 100.
Did you put?
Did you
50
X or
on
did
it?
you the multiplication symbol?
Cause I did that the other day.
A lot of people have done that.
Just push the one that was on.
Where's the X button? Okay.
Let's click that one.
You have equals 100.
Oh, shoot.
That's good. I mean, seriously, something like Garrett just did that. That's good news. Does he do it right? Yeah, he just typed it in wrong. You don't need to worry about typing it in wrong on your test because you're not gonna have a test on computers. Okay. We'll stop there. We'll give you almost a half hour to work on the assignment. Okay, so we'll continue more of this on Monday. Okay.